In this session, I'm going to talk about different kinds of functions and features that are available in R to summarize a variable. I want to create a summary of a variable or summarize the entire data frame. So I'm talking about a few important functions in case we have a table of data. What is that basic summarization that I can perform on it? So this is where I would be talking about if my data is a discrete data, what all can I do on it? If it is a continuous data, how do I handle it? Then the entire data frame, what kinds of basic summarizations? Here the objective is only summarization. So what kind of a basic summarization I can perform on a data frame? And one aspect that I would like to talk about here is, let's say I'm getting the data which is in the form of an Excel spreadsheet or a CSV file. I'm getting that into R. What is that typical step-by-step approach that I should see if I want to inspect the data? So I'll give a kind of an approach to inspect the data. And one interesting function that I would be discussing in this context, especially useful for summarization, is the apply function. Of course, here I would be talking about two other important functions. One is a summary function and the other one is a describe function. So three major functions I am going to talk of in the context of summarization: the apply, the summary and the describe. So let's get started. So whenever we talk about a discrete data, it is those values which occur at specific levels. Let me take one data directly, right? One of the spreadsheets that is there on my system, I'll try to take it into R, right? So I'll call that as sales. I'll do a read.csv. I have to give the path on my system, right? Let me give the path. So this happens to be the path, right? It is on my system. So I'm just giving, this is the path of that CSV file. So I'm taking a sales data. So I'm reading this. So I'm just using read.csv command, and this is the path where that CSV file is typically present. So sales is the name of the variable. And just to give a few functions, sales is the name of the variable which is holding the data frame. If you want, you look at class of sales, I'll see that it is a data frame. And if I want to look at the first few observations, few records that are there in sales, I'll say dim of sales, I'll say head of sales will give me the initial few records, generally by default the first 6 records. Okay, I could see here the store number, the year one, probably year wise, so week wise, sales per product 1, sales per product 2, the price of product 1, price of product 2, whether the promotion is done in that particular week for product 1 or not. 0 indicates that the promotion is not done, 1 indicates promotion is done. P2 prom is again for product 2, and I think country is talking about the country in which the sales have been made. If I want much more details on what are all the kinds of entries that are there, I can do a structure. I'll try to do the structure of the sales. It says that the data frame, 2080 observations, 10 variables are there. The store number, it's showing as integer 101. So there are a few, we have to check how many different types of stores are there. Year again is an integer. Week is an integer 1, 2, 3, 4, 10. Product 1 sales is an integer. Product 2 sales is an integer. Product 1 price is a number. because it is having decimals. Product 2 price is also a number. P1 promotion is 001, so either it is 0 or 1. P2 promotion is also having zeros and ones. Country is treated as a factor with 7 levels. So there is something Australia, Brazil, probably a few countries, C and might be China. So this is what is the structure of this sales data. Now here, these kind of stuff, right? Let's say when I'm talking about promotion being done or not, or countries, right? So the country is more and more of a discrete variable here because very few values are there. So that is where I am calling it as a discrete variable. It occurs at specific levels. So it could be a quantitative, a qualitative or a categorical data quantified as factors, or it could be a numeric data also. Let's see here in the price. I see there are only 4 or 5 different prices, 2.29, 2.49, 2.99, 2.79, only 4 or 5 different types of prices. In that case also I can call it as a discrete data. So where there are only very few finite number of categories of data. That is what it could be, quantitative or it could be a qualitative data, but only a fixed set of values. Then we are treating it as a discrete data. And generally for a discrete data, the best kind of summarization that we can visualize is the frequency. So I can describe it with the frequency counts. How many times each particular variable has occurred. And to describe that frequency, one of the most common functions to use is a table. So let me say I want to use a table of, so this name of the data frame is sales. I want to find out, I want to create a frequency count of, let's say, P1 price. So I'll put $P1 price. So it says 2.19 has occurred 395 times, 2.29 has occurred 444 times, 2.49 has occurred 423 times, and so on. So it looks like 2.19 and 2.99 are slightly on the lower side, whereas the remaining 3 are more or less uniform. The same logic if I want, I can do for P2 price also. So I can check for each one. In case of P2, yes, 2.29 is occurring 429 times, 407. So 2.99 is occurring 384 times in this data. So table is the kind of function which will do the counting, how many times each value has occurred in a particular variable. So the same table, if I include 2 variables, let's say I put table of P1 price, comma sales dollar P1 prom. So what I want to look at is, so how the sales are there for different promotion levels. I want to do the counting that way. So I could get a 2-dimensional. This is what we are calling as a cross tabulation. We get all the values, right? 2.19, 2.29, 2.99. So when the promotion is not done, these are the prices. These many times 2.19 has come. When the promotion was there, these many times the P1 has these many times 2.19 is the pricing. So I can have something like this. So which means table can give either a 1-dimensional scenario or even a cross tabulation when I am using 2 variables. And based on this, let's say if I want to convert the same into proportion, I want to really check how many times, right? I want to typically check the percentages for each one of them. Instead of putting it in number form, right? I want to see how many times the price was 2.19 when the promotion was done as a proportion of the total. So this is where I can still use So from this table, now let me assign this table. So most of the variables in R, most of the functions in R, they can be assigned to variables also. So what I mean by this is, okay, cross tab, cr.tab, right? I am calling it as a cross tab, that I am assigning this table. So this whole table is given a new name called cr.tab, right? Now out of this cr.tab, I can do a computation, right? I'll say cr.tab, I'll take all the rows, but only the second column. So that's where I'll take a subset here, and I divide it by both. So I'll take again cr.tab, all the rows comma first column, plus cr.tab, all the rows comma second column, which is giving me a percentage. So it says, okay, 2.19 has come 10.37% times, right? Or probably I can even do the rounding here, right? This whole thing I can do a rounding, let's say to 3 or 4 decimals. So I could see that this has occurred 10.38% times, 2.29 has occurred 10.36% times, 2.49, 9.93, 10 and 8.53. 2.99 looks that it has come slightly a lesser number of percentage of times compared to the remaining 4. So some kind of operations also can be performed, proportions can be computed. So once the table is done, table can be assigned to a variable, and different kinds of calculations can be performed on the table more or less in the same way as we are performing on the normal data. So that is what I am mentioning here. Most of the functions in R, they produce an object. I can assign that object to a particular variable, I can save that particular object, and I can write future commands on the top of them, right? Then the output table, okay, I got a table, right? So what I can very well do is I can look at the structure of this table. Let me see. So this is my table, CR tab is the table. So what I'll do is I'll look at the structure of CR.tab. So it is saying this is a new structure. Table is a different type altogether. And it is saying, so there are 5 rows in it, 2 columns in it. That is what is the structure of this particular table. So it is even specifying the values and the headings in the rows as well as in the column. So we can look at the structure. Structure will give me the type of that particular output, and if required I can even do a plotting. So plot is a very general function. Let's say on that CR.tab only, I simply say plot CR.tab. Now I could see a very different kind of a graph, right? I am given zeros here, ones here. So there is a separate plotting of zeros and the ones. More or less you see all of them are at the similar height, and it is a breakup between 1 and zeros. So this kind of, so what R does is, in the plot function, depending on the kind of data that we are providing as an input to the plot, here the data that is provided as an input is a 2-dimensional table. So when this kind of a table is provided as an input, we get this kind of a chart. And probably different other kinds of data. Let's say I want to try the plot, right, just to give you a kind of an input. The same plot, if I am doing on the price, one single value, right, sales $P1 price. Now I get a completely different kind of a chart, right? So depending on the kind of input, the type, the data type associated with the input, different kinds of charts are automatically selected by R and they are typically plotted. So we have to understand people from different backgrounds. Let's say from the marketing analyst perspective, if I have to look at, they can use all these kinds of functions to produce weekly reports, monthly reports, sales, web traffic, all kinds of stuff. This becomes a quick working of the quick summary on the various data items. Now, moving on to the next part where I am looking at the continuous data. So when I say continuous data, it's not restricted to just 1-2 values. We'll have a range of values. Now in our case, what is that, which field is containing that continuous values? Let me look at again head of sales. Okay, P1 sales. P1 sales is looking like a continuous. And if I try computing the table of sales dollar P1 sales, obviously I'm getting so many. So right from 73, 76, 77, there are so many occurrences. So in this case, counting really does not make much of a sense. Counts are not much useful for this kind of a continuous data because the number of possible values is too many. In case of price, we have found only 5 possible values, whereas here the number of possible values is too many. So count is literally not useful in this context, which means I need to have a different kind of mechanism for doing the summarization. This is where we talk about creating a summarization for this kind of a data in the form of a distribution. So when I say distribution, I need something to find out the range of the data. The center value, range of the data is maximum minus the minimum value. Center, measures of central tendency in terms of mean, median, etc. Degree to which it is concentrated or dispersed. We can look at standard deviation, variance, interquartile range, mean absolute deviation and median absolute deviations. All these are becoming, so we look at the range, minimum and maximum, centeredness through the mean and the median, concentration versus dispersion using the variance, standard deviation, interquartile range, mean absolute deviation, or in some cases some specific points, quantiles, percentiles, 90 percentile value, 70 percentile value, etc. Or quartiles, we can get 25 percentile and 75 percentile values. So let's say I want to look at all those things on this particular data. So we'll go for sales dollar P1 price. So let me take minimum of sales dollar P1 price. So it says, sorry, I don't want price, I'll take sales. Right, sales dollar P1 sales, I get it as 73, that's the minimum value. Similarly, I do a max. Right, I'm doing a max of it, saying 263 is the maximum value. Then I can take mean, which is a measure of central tendency. So mean is 133. I can take median, another measure of central tendency, which is coming out to be 129. Then I can look at the variance of the same. Variance is giving me 805. Standard deviation supposed to be the square root of the variance. I can use using the SD function, which is the 28.39. Then I could also use the mean absolute deviation using the MAD function, which is giving me 26.68. I can get the interquartile range using the IQR function. So interquartile range happens to be the difference between the third quartile and the first quartile. So let's see, we can find out what is the third quartile. So let me use quantile as a function to get the Q3 value and Q1 value. So I can very well set props. So you could see here, if I want any kind of quantiles, I'll set quantile props, which is the probability levels. So I'll set props equal to, So if I want 25 percentile, I'll set it as 0.25. If I want Q3, which is the 75 percentile, I'll set it as 0.75. So 25 percentile value comes out to be 113, which is the Q1. 75 percentile value, which is the Q3, third quartile, comes out to be 115. The difference between the two is what is my interquartile range, which is what is working out to be 37. So that's how we can compute lot of things. And what we need to understand is, especially if the distribution is very much asymmetric, right, which is what we call as a skewed distribution. Lot of applications in finance, marketing, you will find that they are not much symmetric. So they are skewed either to the left or to the right. So if the data is too much skewed to the left or to the right and not symmetric, then relying on the mean and standard deviation as a measure of central tendency and dispersion is more and more misleading. So this is where in those cases I'll rely more on median and the interquartile range as a measure of the centeredness of the data as well as the dispersion that is present in the data. So I can very well compute the for different kinds. In case the skewness is much higher, right, we did not check the skewness here, but there are ways to check the skewness. I'll come to that in the next slide. There is another formula which can give all these numbers quite comfortably. So once I check the skewness, if it is appearing that it is not symmetrical, then probably I should not rely much on mean and standard deviation as the measures of central tendency and dispersion respectively, but I have to rely more on median and the interquartile range for the same. Then, so this is the thing, if I come across one column at a time, then probably this is what we work with the moment we come across discrete data and continuous data. But many a times the data with which we work is a huge data frame containing several rows and multiple columns. So for each column, if I have to do this kind of analysis, it's going to be a pretty much time consuming kind of stuff. Now this is where I can't apply these functions, mean, medians or standard deviation, to so many columns separately. That is what will eat away too much of my time. Now this is where we talk about using a function called summary function. Very interesting function which I can apply on the entire data frame. So I say summary of sales, straightforward. Now you see a big summary being produced. Store number. Of course, this store number has not much of a meaning. There is, because it's a number of the store, right? But it is still giving me minimum, first quartile, median. So this has no meaning in this context. But yes, look at even the year does not have much of a meaning because we are talking of year 1 and year 2. Not much of a meaning. Week also may not have much of a meaning, but look at the sales. Sales, it is saying minimum is 73. First quartile is 113, that is what we have got earlier. Median is 129, mean is 133, third quartile is 150 and maximum is 263. These are the numbers that we have got when we have separately done using each of the functions. But in the summary, it is executing for everything. You see, for P2 the minimum is 51, much smaller than P1. First quartile is 84, smaller. Median is also smaller. Mean is 100.2. Then we are talking of third quartile at 113 and maximum at 225. So overall it is looking like the overall pattern of the P2 sales is looking like it is slightly, it's much lesser compared to that of P1 sales. Just by a quick look, because mean is also lesser, median is also lesser, minimum, maximum, almost all the values are lesser. The same logic, right? P1 promotion, so mean is around 0.1, In case of P2 promotion, the mean is around 0.1385. So country wise, Australia is there 104 times, Brazil is done 208, CN is China probably 208, right? You find Japan is 416 and US is 312 occurrences. So in case it's a factor variable, you could see the summary. When it is an integer or number kind of a variable, the summary will compute these 6 aspects: minimum, first quartile, median and all that stuff. But in case it's a factor variable, the summary is going to compute the number of occurrences of each of the observations, so frequency. So in case of summary, that is the advantage. If my variable is a kind of numeric, automatically it will compute the kind of descriptive statistics on the top of it, right? Especially the range related minimum, maximums and few things associated with the central tendency and dispersion. Whereas if it is found to be a factor, then automatically it will do the counts process. So summary is a kind of a good way, especially if I want to inspect the data before I do any kind of operations on the top of it. So for every variable, a few descriptive statistics are being produced, right? If in this itself I set some kind of precision, let's say here there are 4 digits that are coming out, I want only 2 digits to be displayed and all, I can give an additional parameter into this summary saying digits equal to, I can set it as digits equal to 2, which will specify the precision of the display. So generally where we will use this summary is, first we import the data. The moment we are getting the data from Excel sheet or a CSV file into R, the summary is used to do a quick quality check. I'll look at the minimum, maximum, see if there are too many outliers present in the data, how far, what is the kind of distance that is there between the mean and the median, are they more or less closer together, or do I see too much of difference or too much of distance between them. All these kinds of things I'm going to evaluate when I'm looking at the summary as a function. Now on the other side, another important function, more comfortable or much more detailed compared to a summary function, is the describe function. But the describe function is not present in the base package. Just for that, if you try describe and I put sales, it says it could not find the function describe, because describe is not there as a part of the base package. So you have to install the package. It is present in a package called psych. Psych is a package which is containing the describe function. So the way you have to install a package is, you go to a package, say install packages, it will connect. So you have to choose some mirror. So let's say I am choosing HTTP mirror. The country closest to me, I am choosing India. And out of this, I am choosing my psych package. Right, I can directly type it saying install.packages, but again, if I am not that comfortable, better I come here, select this psych as a package. So that particular package would be downloaded from the respective server, and all the packages that are very much essential for this particular package to be installed, all the relevant other packages also will be installed along with it. So the package psych is successfully unpacked. So first thing is, so this is a one-time activity. If it is installed once, it is sufficient unless a new version of it has come. Otherwise I can very well do the installation only once. But once it is installed, I have to load it. Now it is there on my system, but I have to load it into the current workspace. So this is what I do using library. Library is a function which will load a package into the workspace. So when I say library psych, now the psych is loaded into our workspace. I can use the features from psych. So now I'll use my describe function, describe sales. Now you could see some kind of a report that it is giving. So there are 10 variables, 1, 2, 3, 4 to 10, right? N is 2080 in all. So there are no missing values for any of these things. The mean value, okay, for some of them it doesn't make any kind of a sense. So wherever it does not make any kind of a sense, we can omit it. But it computes the mean value, it gives the standard deviation, the median. It also computes the trimmed mean. Trimmed mean is some few extreme values on the left and the right. They are directly deleted, and the mean of the remaining things in the middle has been taken. That is what we are calling as the trimmed mean. So for each of the variables, so here you could see the mean of P1 sales is 133.05. After a few extreme values have been removed, now the mean is only 131.08. The same is the case for P2 sales as well. Similarly, it computes the mean absolute deviation, the minimum value, the maximum value, the range, which is the difference between the minimum and the maximum. Skewness. Skewness as a ballpark number, as long as it is very, very close to 0. Typically, I say it should be in the plus or minus 0.5 range. As long as the skewness, on a quick note, just to verify, if it is in the plus or minus 0.5 range, then I can say my data is more or less symmetric. Otherwise, I talk about some kind of a positive skew or negative skew present in the data. In this case, I could say both for P1 sales as well as P2 sales, the skewness is even greater than 0.5, 0.74 in the first case and 0.99 in the second case. So the data is not entirely symmetric. There are some level of extreme values present in both the column. The same is the interpretation I can make with the kurtosis. Kurtosis also, as long as the value is in the range of plus or minus 0.5, I could make out that the values are more or less normal. But the more and more is the kurtosis value going away from 0, I could talk of a lot of values present in the tails. The tails becoming more and more heavier. So in this case, I could say in case of P1 sales, okay, it's around 0.66, but P2 sales, the value is 1.51. So the tails are pretty extreme. So there are a few abnormal values in sales with respect to P2 compared to P1. And even it gives standard error, which is nothing but the standard deviation divided by the square root of n. So it is as good as saying 133.05 divided by square root of 2080. So that is what is being computed as the standard error. So the describe as a function gives me a few more additional variables, additional computations compared to the summary, especially the skewness and the kurtosis, which are very much essential to assess the symmetricity of the data and even the presence of extreme values in the data. So reports a kind of statistics for each variable, and in some cases it has even put a star, especially if the variables are of the type factor. If the variables are of the type factor, it directly puts star, saying probably you have to take these numbers with a pinch of caution, because it's just quantified 1, 2, 3, 4. There is no real meaning to Australia being 1 and England being 2 or whatever. So it's a kind of a quick quantification that has been done. So the results that describe function is giving for these categorical variables which are marked as star needs to be taken with a pinch of salt, because they really don't convey any specific meaning. I can do this on the entire set of variables or even using the subset of variables. The whole data frame I can do, saying sales, or I can take all the rows and let's say only 3 to 5 columns. So like this also I can do the summary function. So if some of the rows don't make and some of the columns don't make any kind of a sense, I can very well omit them from my analysis and I can very well do the summarization of only those columns which make a lot of sense to me. So generally this is a very interesting package, a very interesting function, especially when I am dealing with summarization of the survey data, where a lot of discrete values are there. I've done a survey, collected the opinions of the participants on a Likert scale, probably a 1 to 5 kind of a scale or 1 to 7 kind of a scale, strongly disagree to strongly agree kind of a scale. So if I want to give some kind of quick summarizations on the top of it, it looks like using the describe function from the psych package is much more beneficial. And the star is displayed if the variables are factors, because the statistics that we are computing for them really does not make any kind of a sense. So these two functions I expect you to be very much comfortable with. So as a process, let's say you have got the data from some external sources. So you have used your read.csv, especially if your data is in a CSV format, you are using the read.csv to get the data into R, and you have to check for imported errors. What is the way you can check them? First, convert it into a data frame, right? In case the import is not happening, the error is going to come directly. Once it is imported, better is you convert it into a data frame. That is what I have done as the first step. If you see, sales is a kind of a variable that I have assigned. So this means I have read.csv, but I have taken it into a variable called sales. So the sales became a data frame. If required, I can even change the names of the columns. Right now I have kept them as it is, but if you want to see names of sales, right, these are the names that are associated with the sales, but if I want to change them, I can very well do the same process. Names of sales I can assign to a different set of values. So if some headings are not proper, better to change the names for each of the columns. Then other thing that you can use is dim. Dim is the dimension. So it talks about how many rows and how many columns are there in your data frame. So here it says 2080 rows and 10 columns are there for this particular data frame. Then I have used head already. Head tells me the initial 6 observations, so I can check whether the data is proper or not. Similarly, I can do the tail, which will show the last 6 observations by default. I can change the number as well. But here, okay, this is primarily to observe whether my all set of rows, all set of columns are loaded or not. No blanks, no missing values. Right, the header rows are treated as headers only, not as data, and no rows are missing, no blank rows are being shown, some such kind of stuff. Along with that, just like a head and a tail, I can also use sum. Sum is some random values. So probably let me say sum of sales. Again, the sum does not belong to this package. Sum comes from a package called car. So let me see if it is already there. If it is there, I can load it. Yes, in my system, it's already there. So otherwise, you have to install the package car. So in this case, it is already there. So that's where it is loading it directly. Now, I can simply say sum of sales. So basically, it says it pulls out some random records. Okay, 174th record, 211th record. Randomly, so that I can quickly check. See, if I do this exercise again, I'll get a different set. So basically, randomly some 10 observations are being pulled out and displayed, so that you can quickly check, right? So that you can quickly check somewhere in the middle is something going wrong. So this is one more way to quickly check your data. Then you can use the structure which we have already used, which will talk about the data types for each of the variables that we have. So if at all something is not convincing, better to change the data type of that. Let's say here the store number, it is showing as integer, but I want to make it as a factor. So what is that I can do? So I'll say sales dollar store num. I'll rewrite on the top of it saying as dot factor. I'll convert that into a factor, right? I'll convert it into a factor. Right now it's an integer, so I'll convert that into a factor as dot factor. The same sales dollar store num. So the same original variable called store num now has been converted into a factor. Now if you quickly want to check the structure of sales, now it shows it's a factor with 20 levels. 101, 102, 103, they are treated as levels now. So this is how, in case we want to change, let's say year also, I want to change it as a factor, right? So I can simply again rename, I can overwrite on the top of that itself the old value also. So here as dot factor first will take the old value, which is an integer, converts it into a factor and assigns it again back to the same variable name. So now you could see when I am using structure again for the sales, now this also gets stored as a factor with two levels 1 and 2. So wherever I really see there is no point in doing the calculations, the same thing I can do for the week as well. Week also there is no point in doing the average, mean, minimum, because it's just the week number. So even the week I can prefer to have it as a factor itself. So even the week I can convert it into a factor. Now probably if I'm doing describe now, we'll get so many stars because all these have become factors. So you say describe sales. Now you see for store number, for year, for week and country, for all these four you are getting stars, because as an analyst I really don't make any kind of sense. It doesn't make any kind of a sense treating the mean, standard deviation on these factors. So probably that's one thing that I can do by using the string. I can do a summary now. Summary we have already done. Now for those variables which are factors, summary will do the counting operation. So 101 has come 104 times, 102 store has come 104 times. Similarly, year 1 is present 1040 times, year 2 is present 1040 times. The same is the case for week 1 is present 40 times and so on. So if the variable is a factor, it will do the counting process. If the variable is a numeric, it will typically do the descriptives kind of thing for it. And finally I can load the psych library, and even I can examine the basic descriptives with the describe. So whenever I am getting the data from any other kind of a source, this is what is the process before I do any kind of in-depth analysis on the data. Better check the cleanliness of the data using all these kinds of approaches. Then another important function that I find very useful is the apply function, right? Especially in case of a data frame, using three inputs. First, the data, margin. Margin, if it is 1, it means for every row. If it is 2, it means it is for every column. So whatever is the function that I want to apply, I can say I want to apply standard deviation, I want to apply mean, I want to apply any custom function also. Whatever is the name of the function, If I want to apply it for every row and for every column of the data, then I can use the apply function. So let me use the apply. So I'll say apply. The data is sales. Let me take within that sales. I'll not take all because there's no meaning for row number 1, column number 1, 2, 3. So I'll say 4 to 9 columns because I'll omit even the country column. So I'll take only the 4 to 9 columns of data. Right, so that is what is the data on which I am doing an apply, and for every column I want to apply. So I'll say margin equal to, either I can write margin, I'll say margin equal to 2, which means every column, and I should also write function. What is the function that I want to apply? Let's say I want to do the standard deviation. So it does, okay, for P1 sales, this is the standard deviation. For P2 sales, this is the standard deviation. Now the good thing is, let's say I want to write some custom function, right? Instead of SD, I want to write some function of X, right? Where if I am writing my own function, I am opening a braces. So the kind of custom function that I want to write here is SD of X divided by mean of X into 100. So let's say this is the name of the custom function that I want to write. So that I want to apply across all the columns. Then also it does the computation. So for P1 sales, that's the number, P2 sales, that's the number. So we'll get standard deviation by mean multiplied by 100. So I can write anonymous custom functions also here. And in some cases, especially for means, if my objective is only means, I could have still used this function saying mean. But at the same time, I have separate functions called call means, which is the column means. Column means of sales, all rows, 4 to 9 columns. So even this will give me the same result, but this is only for means. But if I want to, but when I am using the function called apply, I can think of any kind of function to be applied on the data. So that's the kind of an advantage that I am going to derive using apply. Whereas some basic functions like call means, row means, they can do only specific functions on the data, but apply is more and more generic. So if I want some kind of a function mean of X minus the median of X, and that I want to compute, then I can very well use the apply kind of scenario itself. So if I am doing all this on a data table, I can use apply. But if the same thing I have to compute for every table, every column of the table, then I can use it as a T apply, just an extension of the same concept of apply. If I want to do it on a list, I can use L apply. So these are the different kinds of extensions of apply, which can really help us in doing the summarizations of the data quite comfortably. So this is what I wanted to cover as a part of this session. Basically, when I am loading a data from a CSV file or from some other data source into R, what is that first steps that I look at before I start proceeding into an in-depth kind of statistical analysis and conclusion making process. I hope you are comfortable with these various aspects. In case you are not clear on any of them and you require further explanation of the same, you can give me a call on the number that I have provided below, or you can even send in an email at vamsidhar@basegurus.com. Thanks a lot for listening to this session. Thank you very much.